Hello, my name is Ross Kimshrek, and I'm here to present my third milestone for project number two. So I'm going to begin by sharing my screen with you. Okay, so my project was causes of air pollution in the Republic of Korea. I will refer to the Republic of Korea as the ROK for simplicity. Business problem is obvious. Air pollution affects every facet of society. It affects businesses, individuals, it affects the environment. It is not good for any region on Earth. Um, in the Republic of Korea, which is the ROK, has developed over in the past 70 years rapidly. It rapidly industrialized, uh, and with that came a a significant increase in air pollution and also water pollution. Most Koreans think that the main culprit for the rise in air pollution is because of neighboring China. However, this is not factual, and I have in this project evidence to prove that. So I'm going to talk about my data sets. I used up to 16 data sets, and they range from data sets on the actual air pollution, water pollution, and also the number of roads and number of vehicles in the country. And this also makes a comparison. There's a data set for international numbers as well. The main variables, that my target variables are actually PM 2.5 and PM 10. Now, the reason I chose these variables is because PM 2.5 is the main type of air pollution that is affecting people in Korea. So what PM 2.5 stands for is these are particulates that are 2.5 micrometers in diameter, and PM 10 are particulates that are 10 micrometers in diameter. I will be comparing my main target variable, which is PM 2.5, comparing it to SO2, which is sulfur dioxide, NO2, which is nitrogen dioxide, O3, which is ozone and trioxygen, and CO, which is carbon monoxide. I began by running some models on the data, um, and what I used were mainly three different kinds of models. So I used linear and logistic regression models, and then I also used gradient boosting classifiers to handle this data. I'm going to move on to some visualizations here. Um, so these are the 16 data sets that I did use. The first visualization we have here is an area map. Now this shows the world, and it shows that the United States does have the cleanest air on Earth. Uh, in the second visualization, this shows basically regions that are actually affected by air pollution. This tree map once again shows the countries that have the cleanest air, and that is the United States has the least air pollution, followed by Canada, the UK, and then other European countries. And that is supported by this bubble chart. This line chart shows domestically how much the air quality has diminished in Korea over Korea's recent modern history. The red line shows very, very bad, and you can see it's much, much higher than the other categories. This stacked bar chart shows the same thing. In this case, the very bad red is actually in brown, and it's significantly much higher than the others. Here's a comparison of PM 2.5 and PM 10. I do want to mention that we refer more casually PM 2.5 as being small particles and PM 10 are large particles. Here's a box plot of the two variables, small particles and large particles. You can see that there are some outliers here. What I did have to do is I had to transform this data set because what I came to realize was my initial box chart Sorry, I can't show you here. My initial box chart looked like this. So the box chart of this data set, which is my eighth data set, uh, I'm sorry, it looked like this. Um, and the category that is the largest and that is skewing this data is actually called unnamed. So I assume these are just types of air pollutions that can be unidentified. So what I had to do was remove that because you can see from this bubble chart that once again the unnamed takes up the majority of the data. So I had to remove this so that I could produce this box chart. And so what this shows is every particle and then every type of, well, not every type, but of a lot of um, conditions that the atmosphere can have, such as humidity, pressure, uh, rain, temperature, and so on. And so you can see from this box chart, there aren't a lot of outliers in this case after removing that column. So that sort of explains the different types of weather, different types of particles that are contributing to the increase in bad air quality. I just want to show you this chart here. On the left, it's in Korean, but this shows different regions in the Seoul metro area. Now you have to keep in mind that in Seoul metro area, uh, roughly half of South Korea's population inhabits the Seoul metro area. So this is a highly densely populated area. Um, you can tell definitely from this chart that areas uh, with a higher measurement of small particles, that they are the areas that are more densely populated. On the right hand side, it shows from 2005 and then compares to 2023 the number of roads that were in the Seoul metro area. You can tell in 2005, and when you compare it to 2023, there is a huge increase in road construction. And that reflects the number of cars that are being driven in the Republic of Korea. So that directly does correlate. If you look at this last chart, we have a line chart. This is of car emissions from 2000 to 2013. Uh, that there's just been a rapid increase in car emissions, which would be from exhaust, and that does directly correlate with the number of roads that are constructed in the Seoul metro area, which also correlates with small particles and its increase over time. Okay, so that concludes this presentation. Thank you very much for listening and have a great day.